Hello students, welcome to Naran PU College online classes. So in the last video we have discussed about the physical properties of the 16th group elements. Now we will discuss about the chemical properties. Clear? So like what we have discussed in the 15th group, reactivity towards the hydrogen, oxygen and halogen, and here also we will discuss the same concept. Clear? So first one is reactivity towards hydrogen, means what is the formation of hydrides. Formation of hydrides. Clear? No? So 16th group elements and it forms 15th group elements forms, and here H2E type hydrides. H2E type hydrides. H2E type hydrides. Clear? So what is E here? E is a 16th group elements. It can be oxygen, sulfur, selenium, tellurium and polonium. Clear? So polonium I already said it is a radioactive element, short-lived element. So that's why most of the time we will not discuss about the polonium. We will discuss up to the what it is tellurium. Clear? So here if I write suppose oxygen if I put, then what I will get H2O, and sulfur if I put, then H2S, and here H2Se, and next one is H2Te, and last one is here H2PO. These are the hydrides of what it is here 16th group elements. Clear? Now, and second point here we will discuss about the structure of these molecules. Clear? What is the structure? So if I see here, first suppose I will take any one example. Suppose if I take this is oxygen. Oxygen means central elements. If you take electronic configuration, what it is Ns2np4 means 2 electrons are present here and 4 electrons are present in the p orbital. So that's why how many unpaired electrons are present here? 2. So that's why these central elements will make how many bonds here? These unpaired electrons involved in the bond formation. So that's why they will form 2 bonds. So that's why they will have 2 bond pairs and 2 lone pairs. Clear? So that is, first if I write here, what is the central atom hybridization? Clear? Hybridization of, clear? Central atom E. Hybridization of E. E means what it is here? Oxygen, sulfur, selenium and tellurium. So what is the hybridization? Hybridization you know how to calculate. In this one, water molecule if I take, this is the water. Clear? So here lone pair of electrons we will write. Clear it is. So how many bond pairs are there? 2 bond pairs. How many lone pairs are there? 2 lone pairs. So that's why 2 plus 2. Here I will write, will have 2 bond pairs and plus what it is 2 lone pairs. So that's why totally how much here? 4. So that's why what is the hybridization sp3. Clear? And you know that. And second point I will mention here, this compound will have the 2 bond pairs and plus 2 lone pairs. If it is molecule is having 2 bond pairs and 2 lone pairs, then what is the shape of the molecule here? Angular shape or bent shape. What is the shape? Angular shape. Clear? If I write here shape, if I take here it is E, this is the angular shape, or what it is here? Bent shape. So there are 2 lone pair of electrons here. Clear? So this is about the shape of the molecule. Clear? Next one is we have to discuss angle between, this is what is the angle here. Clear? For different molecules. Clear? If I see here, you know that central metal element, central element, not metal, central element if you take, what is the hybridization here? Hybridization is a sp3. sp3 means what should be the bond angle? 109 degrees 28 minutes should be the bond angle. Clear? But in these compounds if you see the bond angles, it is less than the 109.28 minutes. So if you take this is, the bond angle is less than 109 degrees 28 seconds. Clear? Less than means it is less than the 109.28 seconds. Now I will write here the molecule. You see now H2O. H2O means what I can write shape here? Hydrogen, and here hydrogen. And next sulfur, if I take hydrogen and here H2S sulfur, oxygen sulfur, You know, selenium. Selenium here hydrogen, and here also hydrogen. Last one is tellurium, I will write. Clear no? So these are the compounds. Clear? If you see in this case, what happens here? There is a lone pair of, clear no? Here lone pairs are there. Clear? When you take this is lone pairs, you know that here lone pair and lone pair, due to the strong lone pair repulsion than the bond pair. Got the point here? Suppose if I take simple example, this example only I will take. I will not write all here. You see, this is hydrogen and this is hydrogen, and here there is a lone pair of electrons. Here pair of electrons are there. Clear? You know that when they are lone pair of electrons, these lone pair repulsions are always stronger than the bond pair repulsions. Clear? So what will happen? And due to this repulsions, to avoid this repulsion, this will come this side and they move away from each other to avoid that repulsions. To avoid that repulsions, these two will move away from each other. Then they are coming close to what it is, bond pair electrons here. Clear? Then what will happen here? Lone pair bond pair electron repulsion takes place here. To avoid that repulsions, these two bonds will come close to each other till they experience the repulsions. So then automatically what will happen? Previous are here and bond angle will decrease. So that's why if you take here the bond angle in these compounds, those are less than 109 degree 28 minutes. Clear? If you see here water molecule, if you take water, what is the water? You already know. Clear? H2O. I will write first of all H2O and here H2S and take H2Se and H2Te. If you take here bond angle, clear ma? What it is ma here? Bond angle order, and this is the bond angle order. Clear ma? What is the bond angle for the water molecule? 104.5 degree, and here 92.1 degree, and here there is a 91 degree, and here 90 degree. Clear ma? If you are moving from the oxygen to tellurium, what will happen here? Bond angle decreases. Why bond angle decreases? You see, and you know that here there will be a hydrogen and here there will be a hydrogen. It has a pair of electrons. Clear ma? So here these are common, but you see now in this case what will happen to the bond angle. And you know oxygen and hydrogen, which one is more electronegative? Oxygen. So that's why these bond pair electrons are close to which one? Oxygen. And these bond pair electrons are close to oxygen because oxygen is more electronegative, it drags the electrons towards it. Now here what will happen? These bond pair electrons are very close to each other. So that's why there will be a repulsions, and to avoid this repulsion, this bond will move this side and this bond will move that side. Then what will happen? Previous like this, and they are moving away from each other. Then what will happen? Bond angle increases. Clear ma? So that's why, and the H2O molecule will have, you know, high bond angle here, large bond angle. And take here H2Te. Clear ma? Here what it is? Tellurium is there, and here there is a hydrogen. And here there is a hydrogen, there is lone pair of electrons here. Clear? Lone pair of electrons. Clear? Then what happened? Tellurium and hydrogen, you know, as we are moving down the group from the oxygen to tellurium, electronegativity decreases. So that's why these bond electrons are close to which one? Almost, you know, close to hydrogen, because tellurium is less electronegative than compared to the hydrogen. Then what will happen? You see in this case, and these bond electrons are away from each other, and here distance between these bond electrons are large, so that's why away from each other. So that's why they will come close till they experience the repulsions. So automatically what will happen? Bond angle decreases. So that's why for water bond angle is 104.5 degree, and for H2Te it is bond angle is almost how much here? 90 degree. And this is the what is bond angle and what is hybridization of the hydrates of 16th group. Now properties of hydrates. Clear? You know that water is in which form? Liquid form mainly. Water is available in liquid form, and remaining hydrates, if you take the H2S, these all are in the form of gases. Clear ma? H2O is It is a which one ma? H2O is liquid. H2O, it is what it is ma here? Liquid. Clear? Remaining hydrides. Hydrides like what it is ma? H2S and H2Se and H2T. These all are which one ma here? Gases. These all are which one ma here? Gases. Clear? Now, and this is the first property. Clear ma? So next one. So second one here is, this is the first one, and the second one, melting points. Clear ma? So melting points. Clear? As I already mentioned previous, melting and boiling points depends upon which one? Depends upon the size. Clear ma? Or depend upon the molecular mass of the molecule. As the molecular mass of the molecule increases, automatically size increases, and size increases, van der Waals forces also increases. When van der Waals forces increases, melting and boiling points also increases. Clear ma? So what should be the order here? As you are moving from the H2O is there, from H2O, H2S and H2Se and H2T. If I take, because I said already polonium is radioactive, so those compounds are very unstable, we will not discuss about them. So that's why here you see in this case what happened ma? And molecular mass, you see all cases hydrogens are same, oxygen, sulfur, selenium, tellurium. If you are moving from the oxygen to tellurium, what will happen? Size increases. Size increases, van der Waals forces also increases. So that's why in this case, and H2Te should have the highest melting point. Why ma? Because it is molecule is a bigger in size compared to H2O. Or calculate the molecular mass. Molecular mass, if you calculate, you will get highest molecular mass for this one. As the molecular mass increases, also van der Waals forces increases, then melting and boiling points increases. This should be the order actually. But what is the order here is, this is the order. Clear ma? So why means, you already know previous also we have discussed for the NH3, because and a strong intermolecular hydrogen bonding existed in water molecule. Clear ma? So water molecule can form what it is ma? Hydrogen bonding. So that's why it will have the highest boiling point. So here the highest boiling point or melting point of water is due to, clear ma? So here highest melting point of H2O is due to which one ma? Due to intermolecular hydrogen bonding. Intermolecular hydrogen bonding. Clear? Like NH3, H2O also will form. Like you see here, suppose water is there. Shall I write, if I write here like H, and here there will be a H. Clear ma? So like if I write there is a H and here H, then what will happen ma? You see there will be a hydrogen bonding here. So it will also, they will also involved in the which one ma? Hydrogen bonding. So like that. Clear? It is. So there are involved in the hydrogen. These are also involved in the which one ma? Hydrogen bonding. This we will call as a same intermolecular hydrogen bonding. Due to that, it will have highest what is melting point. Remaining, they cannot form the hydrogen bonding. Clear? As the size increases, electronegativity decreases means they cannot form the hydrogen bonding. So this is about the which one ma here? Melting point. Same here, boiling point. The third property here is boiling point. Same. Boiling point also, it depends upon the size. As the size increases, melting and boiling points increases, because van der Waals forces increases with the size or molecular mass. So that's why what should be the order here? In this case also, H2S is less than H2Se is less than H2Te is less than H2O. Here also same reason. Why H2O will have highest boiling point means due to the intermolecular hydrogen bonding. That only the reason you have to write the same reason here. Highest boiling point of water is due to intermolecular hydrogen bonding existed in water molecule. Clear ma? And the next one here, bond length. Bond length means that is EH bond. E means what it is ma? oxygen OH bond and sulfur H bond, and that is clear ma. You know that here in this one what will happen, clear. And water molecule if I take, you know, H2O if I take, clear ma. Here there is a H and there here is a H, you know. This is a oxygen is a small molecule and hydrogen also small molecule. When and small molecules are there, those orbitals overlap takes place very effectively. So that's why bond is, you know, bond takes place, you know, bond is very strong. So that's why here what will happen ma, this bond length will be very short, clear ma, compared to here. Here if I take here, you know, H2TE, TE means, you know, this is clear ma here. So what will happen if you take the bond length, this is small atoms here, so this is the bond length, clear. So automatically what will happen, bond length increases as the size of the central atom increases. Automatically what will happen, bond length increases. Bond length increases, automatically bond strength decreases. So that's why what is the bond length order here is, if I take H2O is less than H2S is less than H2Se is less than H2Te. This is means here TeH bond is a, you know, it is bond length is longer, clear ma. So in the same way, fifth one, bond strength. What about the bond strength? What about the bond strength, clear ma? You know, bond length and bond strength are inversely proportional. If the bond length is longer and that bond strength will be very small, means very less, clear ma. Take the here long stick, clear. Long stick if you take, and we can easily break that one, but you take the same stick in the very short stick, short stick you take and try to break that one, you have to, we cannot break easily. Same here, clear ma. So if bond length increases, bond strength decreases. So that's why what about the bond strength here? H2O is greater than H2S and HTSE H2Te. This is the bond strength, clear ma. Next, sixth property. What is the sixth one here? Stability. Clear ma. Stability of these hydrides, clear ma. The stability depend upon which one ma? Bond strength. And here oxygen and hydrogen bond is very strong compared to the hydrogen and tellurium bond. So that's why bond strength increases, stability also increases. That is, so what is it ma? H2O is greater than H2S is greater than H2Se is greater than H2Te, clear ma. And the next one, seventh one is here acidic nature. What it is ma here? Acidic nature. What about the acidic? Means you know that most of these oxides are, you know, acidic in nature, because you know all these are what are my non-metals. Non-metal oxides are acidic in nature mainly, means acidic character decreases down the group, but acidic nature we will say. And acidic nature means what is ma? The compounds which gives the H plus ions easily, and those we will called as a acids, clear ma. So in this case, which one gives the hydrogens easily, H plus ions easily? To give the hydrogen H plus ion, the bond should break easily. The bond between the hydrogen and tellurium or the bond between the oxygen and hydrogen should break easily. So which bond will break easily here? You know, oxygen and hydrogen, this bond is very strong, but here hydrogen and tellurium bond is very weak. So that's why it breaks bond and it gives the H plus ions very easily. So that's why, so which one is the strong acid ma here? H2Te is a strong acid compared to the which one ma? H2O. So what is the order here? H2O is less than, H2S is less than, H2Se is less than, what it is ma? H2Te. This is more acidic. Tellurium hydrates are more acidic than the oxygen hydrates, clear ma? So this is acidic character. Next one is reducing character. Next one is reducing character, clear ma? So reducing character we have already discussed in the previous also. Reducing character means what ma? So act as a reducing agent, clear ma? Reducing agent means these molecules, these should act as a reducing agent. Reducing agent, what it will do? It reduces other substances by providing which one ma? Hydrogens. By providing hydrogens. all these molecules are having hydrogens only, but which gives the hydrogens easily to other substance, and that is the powerful reducing agent. All can give hydrogens here. Reducing agent means it reduces other substances by providing the hydrogens. Clear ma? So which can give the hydrogens very easily, and that act as a powerful reducing agent. So among this, which can give the hydrogens very easily? Because this can give hydrogens very easily because tellurium and hydrogen bond is very weak. So that's why what you will get here, same H2O is less than, H2S is less than, H2Se is less than, and H2Te. Clear ma? So these are about the what it is reactivity towards the hydrogens. Clear ma? First bond angle also we have written, bond angle. So previous I have written bond angle order also. Clear ma? So these all are very important for the which one competitive examination. So next one is reactivity towards oxygen. Reactivity towards hydrogen we have completed, formation of hydrates. And now reactivity towards oxygen, that we will call as the formation of oxides. Clear ma? So here mainly 16th group elements forms two types of oxides. One is dioxides and another one is trioxides. E means what ma? E is equal to sulfur and selenium, tellurium and polonium. Polonium we will not discuss much about polonium. Clear ma? So these are what it is here, oxide. Because oxygen why I have not written, because these are forming oxides means those will react with oxygen only. Other elements should react with oxygen. Clear? So that's why I have not written here oxygen. So sulfur, it can form sulfur dioxide, dioxides and trioxides. Trioxides means what is the formula you can write here, EO3. Clear no? So this is all elements can form the dioxides and also what it is trioxide. Sulfur dioxide, selenium dioxide, tellurium dioxide and polonium dioxide. In the same way trioxides also. So that's why 16th group elements forms how many type, which type of oxides? Two types. How many types? Two types. One is dioxides and another one is trioxides. The formula is for dioxide is EO2 and for trioxide is EO3. So first we will discuss about the dioxides and after then we will go for what it is here, trioxide. Clear? So put the heading here, dioxides. Put the heading dioxide. Clear? Put the heading here, dioxide. Dioxides. Clear? So here all elements forms the what it is here, dioxides. Write the first two. All elements of 16th group, all elements of 16th group forms what it is here, dioxides. Clear ma? Dioxides. Okay. So I already mentioned here. Now in this dioxide, SO2 is a gas. SO2 is a what it is here, sulfur dioxide is a gas. And if you take selenium dioxide, it is a non-volatile, so it is a white volatile solid. White volatile solid. White volatile, which one here? Solid. I am writing about the nature. So SO2 is a gas, SeO2 is a what it is white volatile solid. And the next one is TeO2 and POO2. Both are non-volatile crystalline compounds. These are which one non-volatile crystalline solids. Crystalline solids. Non-volatile crystalline solids. Clear ma? And next point, that these are sulfur oxides. Oxides of 16th group elements are acidic in nature mainly, but the acidic character decreases from the sulfur to tellurium, or you can say polonium. Clear ma? So that in this case SO2, if I take SO2 and SeO2, both are in which one acidic oxides. Both are which one here, acidic oxides. And TeO2, it is a amphoteric oxide. It is a amphoteric. What is meant by amphoteric? Amphoteric means what it is ma? And it can show the both the acidic nature and basic nature. And I will, if I write, we need not to discuss this one, POO2. You know, metallic character increases. Metallic means for sulfur to, if you are going to, from the sulfur to polonium, you know, metallic character increases. So it is a metal oxide. Metal oxides means which one? Mainly basic. It is also so some amphoteric with the more basic character. Clear ma? So these are about the oxides. Means if you dissolve SO2 and CO2 into the water and give the respective acids. Suppose if I take here SO2, dissolve in water, what you will get ma? H2SO3, sulfurous acid. So that's why it is a acidic oxide. In the same way, and take the SeO2 plus H2O, and what you will get ma? Selenous acid, H2SeO3. Clear ma? So these are what it is about the you know, acidic nature. Next one here, you know what will happen to the acidic nature? Acidic nature decreases. Write that point here. Next one, acidic nature of dioxide, acidic nature of dioxides decreases. Dioxides decreases from SO2 to what it is ma here? POO2. SO2 to what it is ma here? POO2. This is acidic nature. Clear ma? And the next point, if I go for next point here, and both means here dioxides of 16th group can act as you know, both oxidizing and reducing agents. Both oxidizing and what it is ma here? Reducing agents. Clear ma? Why? You already know that here. They will show mainly, you know, 15th group, 16th group elements. They can show the +2, +4 and +6 oxidation state. And you know, these are dioxide. Dioxides means what is the oxidation state ma here? +4 oxidation state. So that's why they can undergo oxidation and they can also undergo reduction. If they undergo oxidation, they act as a which one? Reducing agent. If they undergo reduction, they act as a oxidizing agent. So that's why they can act as a both oxidizing and reducing agents. Clear ma? So these are the some points regarding to the what it is ma here? Dioxide. If I take here, you know, what is the structure of these molecules? Clear ma? So what is the structure of these molecules? If I take here, suppose SO2, if I take SO2 means what it is ma? This is sulfur and a double bond, and here there is a double bond. Clear ma? So here 4 bonds are there and it will have one lone pair of electrons here. Clear ma? So what you can write here? How many sigma bonds here are there? 2 sigma bond and 2 bond pairs and 1 lone pair. How many bond pairs ma? There are 2 bond pairs plus 1 lone pair. So because we will not consider pi bond in the hybridization, then what you will get ma? You will get the total 3. 3 means what it is ma? sp2 hybridization. What it is ma here? sp2 hybridization. But here what you are getting here? 2 1 you are getting. 2 1 means what is the shape of this molecule? And molecule shape is what it is ma? Angular shape or bent shape you can write. What it is ma here? Bent shape. And what this is the what it is ma here? sp2 hybridization. I will not write all details here. Clear ma? So it is sp2 hybridization. Clear ma? So angular shape you can write. And this is you know in which state ma? It is in gaseous state. Clear? In the same way, selenium dioxide. In the same way, what it is ma here? Selenium dioxide angular structure will have. This is what it is ma? The shape of this molecule is angular shape. What it is ma? Shape here? Angular shape. In the same way, selenium dioxide will have the same here S double bond O and here S double bond O. This is the shape of the molecule. Which one ma here? Angular and monomer. It is what is ma? Angular shape. It is monomer. In which state ma? Gaseous state. gaseous state. In the gaseous state, it is in the form of which one here? Monomer. Clear? But if you take here in the solid state, it is in polymeric form. In solid state, SeO2 is in polymeric form. Clear? Means if I write here, this is Se and double bond O and O, and here Se double bond O and O, and here Se double bond O and O. Clear? So this is about the what it is here, dioxide. And you know this system all form the dioxide, and SO2 is gas. These are what it is white volatile solid. It is non-volatile crystal, and you know acidic character, and they can act as a both oxidizing and reducing agent. And shape hybridization is sp2 central atom, angular shape. And you know this is SeO2. It is a monomer in gaseous state, but in the solid state it is in which one? Polymeric form. So this is about dioxides. So dioxides we have completed. Now trioxides. Clear ma? See some points here I have written. All the elements of this group forms trioxides of the formula EO3. Clear ma? So next one, like trioxides are also acidic in nature, like you know, because I already said non-metal oxides are mainly they are in form of what it is, they are acidic in nature. Clear ma? But acidic character changes. Clear? So that is trioxides are also acidic in nature, but their acidic strength decreases from sulfur trioxide to tellurium trioxide. Clear ma? If I take here same previous like SO3 and SO3 sulfur trioxide and SeO3 are acidic in nature, and TeO3 is a amphoteric, and POO3 is a slightly basic in nature. That we have not written because you know that is highly unstable compounds those it forms. Clear ma? So that's why here acidic means when you add these two water, your previous you are getting SO2 plus H2O, you got there sulfurous acid H2SO3, but here what it is my SO3 plus H2O H2SO4 sulfuric acid. In the same way selenium trioxide dissolved in water and gives the selenic acid H2SeO3, there selenous acid with the SeO2 selenous acid with the SeO3 selenic acid. Clear ma? So you know all trioxides act only oxidizing agent. Why ma? What is the oxidation state of trioxide? Central metal atom plus 6, because you know -2 and -2. What it is here? +6. +6 means you know, and mainly they will exhibit the +2, +4 and +6 oxidation states. 16th group elements mainly they show the +2, +4 and +6 oxidation state. What is the highest oxidation state of the 16th group elements? Its group number, that is a 6th. Clear ma? So that's why trioxides, the central atom in the trioxide is in its highest oxidation state. Clear ma? So that's why they cannot further oxidized. Clear ma? So because there is nothing, so that's why it only what it is ma? Undergo reduction. Clear ma? It cannot increase its oxidation state beyond 6. Clear ma? So that's why what it will do, it undergo reduction. +5 6 to +4 or +6 to +2, what is a decrease in the oxidation number, automatically we will call as a reduction. Reduction means they can only act as a oxidizing agent. They undergo reduction means they act as a only oxidizing agent. But dioxides, they can act as a both oxidizing and reducing agents. Clear ma? So that is, and now if you see the structure of this molecule, and you know this is central metal atom, how many bond pairs are there? 1 2 3. We will consider only the bond pairs, means sigma bonds, not the pi bonds in the calculation of hybridization. So that's why how many bond pairs are sigma bonds are there? 1 2 3. 3 sigma bonds. Is there any lone pair on the central metal atom here? No. When it is using all its 6 electrons, it won't have any lone pair. So that's why you know it is a sp2 hybridized, and so that's why it is a triangle, trigonal, planar shape. Clear ma? And this is the you know SO2, and in the gaseous form, you know SO3 is a gas. SO3 is a what it is ma? Gas. So in the gaseous form, you know it is in the form of what it is ma? Monomer. But if you take here dimeric means it is a gaseous form. If you take in solid form, it is available in the linear shape and also tricyclic trimer in the form of what it is in the solid state. SO3 exist as a what it is here, linear shape and also what it is here, cyclic trimer shape. Trimer. See here, what is the linear shape means? This is S double bond and double bond O, and here there will be a O, and here O, and this is clear ma? So again S double bond O, and this is clear ma? This is what it is ma? Linear shape. This is what we will call linear chain, clear, or linear shape. And if it is another one is cyclic trimer. Cyclic trimer means what it is ma? This is trimeric form. So S double bond I will write here, trimeric form I will write here. Clear? So here I already mentioned the structure of here SO3 molecule. It is in gaseous state, it is in the form of monomer, but in the solid state SO3 existed as linear chain or cyclic trimer. This is the linear chain of the SO3 molecule, and this is the cyclic trimer. What is this one ma? Cyclic trimer. And these are, when they exhibits this cyclic trimer and linear chain forms, when it is in solid state. In the same way, if you take the selenium trioxide, it is what it is here, selenium trioxide, it is a monomer. It is a what it is here, monomer in gaseous form. In which form here? Gaseous form. It is in gaseous form. But if you take it is in solid form. In the solid state, clear, and SeO3 exist as what it is ma? Cyclic tetramer. Clear ma? You see here Se1, 2, 3 and 4, it is what we will call ma? Cyclic tetramer, and this is about the what it is ma here, trioxides and dioxides of 16th group elements. So we have completed for reactivity towards the hydrogen and reactivity towards the oxygen, and the next topic is here reactivity towards halogens, formation of halides. Clear ma? So here 16th group elements mainly forms 4 types of halides. One is hexahalides, tetrahalides, dihalides and monohalides. Of the formula I will write here one by one. And EX6, what it is here, hexahalides. Next one is EX4 and tetrahalide, EX2 dihalide, EX monohalide. Of formula EX6, EX4, EX2, EX respectively. Clear ma? So how many types of halides 16th group elements can form? 4 types. Clear? So it is, what is E here? E is equal to 16th group elements like sulfur, selenium, tellurium mainly. Clear? What is the X? X can be fluorine, chlorine, bromine and iodine. Clear ma? So first we will discuss about hexahalides, and after then we will go for tetra, di and mono. Put the first heading here, hexahalides. Clear ma? So what is the formula here? EX6. This is clear. And mainly only fluorine can form hexafluorides. Clear ma? Remaining chlorine, bromine and iodine cannot form the hexahalides. Clear? Only which can form? Fluorine. So that you write the first point here. Only fluorine forms hexafluorides. Clear ma? So what are main hexafluorides here? Suppose if I take sulfur, SeF6, so hexafluoro means sulfur here, sulfur hexafluoride you can say. And next one, selenium selenium hexafluoride and tellurium hexafluoride. Clear, ma? So first we have to discuss one by one here. If I take here SeF6 hexafluoride, sulfur hexafluoride, and you know it is gas. It is what it is here, gas, and also very stable fluoride, and chemically inert. It is chemically inert. You know, if it is stable, it is a chemically inert. So what is the reason for chemically inert means, you know, and sulfur surround the sulfur, how many fluorine atoms are present here? 6 fluorine atoms, and these 6 fluorine atoms protect the sulfur from the attack by any other reagent. So that's why it is a chemically inert. Clear, ma? Suppose if I write here sulfur, what is the here sulfur structure? If I write here fluorine, and there will be a fluorine here. How many fluorine atoms are there, ma? 6 fluorine atoms. Sulfur being a small in size, you know, here 6 fluorine atoms are there, and these 6 fluorine atoms, you know, and protect the sulfur from the attack by the other reagents. So here reagents cannot attack on the sulfur. Even, you know, hydrolysis can also will not take place, and SF6 cannot undergo, you know, even simple hydrolysis also. So that's why here SF6 is a, you know, very stable molecule and chemically inert. What is the reason for chemical inertness here? And because 6 fluorine atoms protect the sulfur from the attack by the other reagents. So that is the reason for chemical inertness of this compound. If I take here hydrolysis, do the hydrolysis for these compounds. Just now only I mentioned, and you know, when we are moving from the sulfur hexafluoride to tellurium hexafluoride, clear? And if you go for tellurium hexafluoride, you know, tellurium is a bigger in size. So that's why here what it is, ma? How many fluorine atoms are there here? There are 6 fluorine atoms. As the size increases, you know, what will happen, ma? And these 6 fluorine atoms cannot protect the central atom from the attack by other reagents. Here some gap will be there, you know. See here in this case, fluorine and fluorine, there will be some gap. So that's why reagent can easily attack. Why? Because here the central atom size increases. So that's why automatically what will happen, they are more reactive compared to the sulfur hexafluoride. So easily can undergo hydrolysis. So now what is the hydrolysis? Reactivity towards the hydrolysis here. First one is TeF6 is more reactive compared to the SeF6, and you know, SeF6 is a almost, it will show the inertness. If you take here TeF6, do the hydrolysis, what the compound you will get, you see, do the hydrolysis. How many fluorine atoms are there? 6. So that's why 6 hydrogens required to remove the HF. Then what is left here? 6 hydrogens are left, H6 and Te. How many oxygens left? This is telluric acid. Clear, ma? So this is about the what it is, ma? Hexafluoride. And now we have to discuss about the structure of hexafluorides. Clear? Hexafluorides. Why we have not discussed about the other halides, like, you know, chlorides, bromides and iodides? If I take here chlorides, Sl6, if I take, you know, it won't be existed. Why? Because sulfur and here's chlorine, 6 chlorine atoms are there. If I take like this, chlorine atom is bigger in size. Whenever it is bigger in size, you know, between the chlorine atoms there will be a repulsions. Automatically the molecule become unstable. So that's why only fluorine can form the hexafluorides, not other halides. Clear? So structure, if I take SF6, if I take, you know, this is, take the SF6 example. How many bonds are there with the central atom? Central atom can form how many bonds here? 6 bonds. Is there any lone pair on the sulfur? No. Why? Because you already know that sulfur is forming, means the sulfur is having 6 electrons. All these 6 electrons are used to form a bond. So that's why. And here, what is the hybridization of sulfur in this case? Sulfur hybridization, right here, hybridization hybridization of sulfur, or you can say central atom. Clear ma? So what it is here? sp3d2. Why ma? Because it will have how many bond pairs here? 6 bond pair. Is there any lone pair? No, there is no lone pair. So 6 plus 0 6. 6 means what it ma? sp3d2. So what is the shape of the molecule? Octahedral. Octahedral shape. Clear ma? So what is the octahedral shape here? Draw the structure, octahedral structure here. Clear? Right, octahedral. This is central matter, central element. Clear ma? So draw in this way. There will be a square line. Clear? So here, what are there? Fluorine atoms. These are fluorine atoms. Fluorine, fluorine, and here fluorine, fluorine, and this is structure of which one ma here? SF6, octahedral. You can take SEF6 also. So this is about which one ma here? This is about hexahalides. And next we will go for hexafluorides. So next one is tetrahalides. Clear ma? So among tetrahalides and tetrafluorides are most stable. Compared to the tetrachlorides and tetraiodides, which one is most stable ma here? And the tetrafluorides are most stable. Clear? So in this case, SF4, tetrafluorides means I will take what is the EX4 is the tetrahalides, and if I take E is a sulfur and X is only fluorine, because fluorides are most stable. So SF4 is a gas and SeF4 is a liquid and tellurium tetrafluoride is a solid. Clear ma? They can act as both Lewis base and as well as Lewis acid. Why? Because you already know that if I write here SeF4, clear ma? So what is the sulfur electronic configuration? NS2 NP4. In the first excited state, what will happen? You see, one of this electron will jump into the d orbital. Clear ma? 1 2 3 4. How many unpaired electrons are present here? 4 unpaired electrons are present. So that's why these 4 unpaired electrons are used in the bond formation. So that's why sulfur is forming how many bonds here? 4 bonds. Here one lone pair electron is there on the sulfur. So that's why tetrafluorides, if you take the central element, will have one lone pair of electron. So that's why if I take here SF4, it is having what it is ma? Lone pair of electron. It is lone pair of electron means it can donate this lone pair of electrons to others. So electron pair donor, what we will call? We will call as a Lewis base. So that's why it can act as a what it is ma here? Lewis base. If I write one example here, SF4 plus BF3, I will write boron trifluoride. It is a electron deficient and it is a electron rich. So that's why what it will do ma? It gives one pair of electrons to boron and form a coordinate bond. So here SF4 and here there will be a coordinate bond. So now in this case SF4 act as which one ma? Lewis base, and it is having empty d orbital also. If anyone gives the pair of electron, it is ready to accept also. So that's why can also act as a what it is ma? Lewis acid. Suppose SF4, if anyone is giving electron, fluorine is giving electron, it will be converted into SF6 2 minus. Now it is gaining electron, so act as a Lewis acid. Clear ma? So SF4 can undergo hydrolysis easily, but SF6 cannot. Why? Because their sulfur is surrounded by the 6 fluorine atoms. So this fluorine atoms, you protect the sulfur, but here how many fluorine atoms are there? Only 4 fluorine atoms. So attack takes place very easily. So that's why it can easily undergo hydrolysis and gives what it is here. Take the 2 moles and 2 hydrogens and 2 fluorines will be removed. 4 fluorines will be removed as a 4HF plus what is left here? SO2. But if I write same thing here, SF6 plus 2H2O, what I will write ma? No reaction. This is important. No reaction. Clear ma here? So that is tetrafluoride. Tetrafluoride can easily undergo hydrolysis, but hexafluorides can also, but SF6 cannot undergo hydrolysis. hydrolysis. Clear ma? If I write here structure of this tetrahalide, you know, central metal atom hybridization is what it is ma? sp3d. Why? Because how many bond pairs are there? 4 bond pairs, and here one lone pair is present, so that's why one lone pair, total how much ma? 4 plus 1 5, sp3d. So 4 1 means it is structure trigonal, you know, pyramidal shape or seesaw shape. So one of the lone pair is occupy the equatorial position, equatorial bond, and remaining 2 hydrogens are there here, you know what it is ma? Here axial position, and remaining 2 are at equatorial position. Clear? And this can also be called as a seesaw structure, and this is about the tetrahalides. So next one is dihalides, that is EX2, means all elements except selenium form dihalides, except what it is here, selenium form dihalides, and nothing matter here, and except selenium will not form dihalides here, remaining forms dihalides. Structure, if I take one example here, SeCl2, so here you see what is the hybridization. Sulfur is forming how many bonds here? 2 bonds. 2 bonds means how many electron it will use? It will use 2 unpaired electrons, so it will have how many lone pairs here? 2 lone pairs, 2 bond pairs and 2 lone pairs, so that's why 4 total. How much more? 4 means what it is? sp3 hybridization. Central atom is having, whenever sulfur forms 2 bonds, it will have 2 lone pairs, so that's why 2 bond pairs and 2 lone pairs. So when 2 bond pairs and 2 lone pairs, what is the shape? Angular shape, and this is like water molecule, the shape is like this. In the next one, and monohalides. Clear ma? EX, monohalides. You know, most of the monohalides are dimeric in nature. They are not in the form of, you know, simple monomers. They are in form of which one ma? Dimeric in nature. S2Cl2. Actually SCl we have to write, but it is not in the form of you know, SCl. They are in the form of dimeric form. S2Br2, SCCl2, and this is very important here for competitive. These dimeric halides undergo disproportionation. Disproportionation means what is ma? Undergo, same element undergo both oxidation and reduction. See here SeCl2, what is the oxidation state here? +1, and here what is the oxidation state? +4 and 0, and +1 to +4 is a oxidation, and you know +1 to 0 is a reduction. So it is undergo what it is ma? When they decompose, they undergo what it is here, you know, disproportionation reaction. And the structure is similar to hydrogen peroxide. What is the hydrogen peroxide structure? Open book structure. This is, instead of here oxygen, what you have to write here? Sulfur, you write SiO2 means what you have to write ma? Sulfur. This is open book structure we will call. Chlorine, and here what it is ma? Chlorine. Like you see, it is like a open book structure. This is what it is ma? Here open book structure. So this is about the which one ma? Here, and the halides, reactivity towards the halides. Clear? So now we have completed here, you know, chemical properties also.